Okay, welcome to grade 10 math. We're starting a new unit for solving linear systems, and there's three methods to do this. We are going to start with today's lesson, lesson 1, solving by graphing. So by the end of today's lesson, we will be able to solve linear systems by graphing two lines and identifying the point of intersection. Okay, so we want to try this minds on activity that brings us back to even last year, learning how to, and an earlier unit of graphing these lines. So I want you to pause the video and try to graph this line for me. Okay, so then we're back now and we remember how to graph this. Well, the easiest way we learned from last unit was that we want to isolate our y. And so we have to do inverse operations. So 2y plus x equals 4. Probably going to bring the x over here and slowly get the y by itself. So we're going to have negative x now plus 4. We're going to divide everything by 2 now. So when we see this combination here, we know we're going to have a negative 1 because there's a 1 in front of the x over 2. And we know this can reduce. 2 goes into 4 twice. And of course, the y is by itself now. So this makes it a lot easier to graph. We have b equals 2 and m equals 1.5, negative 1.5. So when we bring this to graph, we find b at 2, and then we want to rise a negative 1 actually, and then over 2. So our second point goes down here. And then finally, again, if you don't have a ruler today, you should probably gather a ruler and have your calculator nearby with a pencil and perhaps some different colors. Always good when you're graphing to do this properly, and these lines are going into space in all directions, in those two directions, infinitely. So remember we had our rise of negative 1 and the run of 2. Okay, so it's going to be really important for us to know how to graph this in this lesson, so it's a good recap to do that. All right, moving on. We get into today's actual lesson. So today we want to be able to find a linear system. Now, when a linear system is when two or more equations are used in a model of a problem, then it's called a system of equations. You could have 2, 3, 4 lines that all are going to intersect or interact somehow. We find a solution between these two lines when the solution of the linear system is an ordered pair, so an x and y coordinate, that satisfies all the equations in the system. On the graph, it tends to be a solution is the point of intersection. And just for short, we usually say the POI. So we're constantly looking for the POI in these problems. Well, we have steps to solve this. So what we do first is graph the line, each equation on the grid. We're going to use the skills we've learned in the previous unit to be able to graph these properly. Locate the point of intersection of the lines with a hand-drawn graph. You may not be able to find the exact solution. Sometimes they fit in between grid lines, and it could be a bit of a guessing game, but certainly an accurate guess or a logical guess, a range of answers is satisfactory. To verify your solution, what you can do is substitute the point of intersection, so the new xy intercept that you just found, into a t-chart, like a left side equals right side, And when you put those numbers in, if it's accurate, then you'll find that the left side is equal to the right side. So, okay, so use the graph below to answer the following questions. Determine the equation of each line. Okay, so sometimes it's good to name one equation A and one equation B. So let's say we want to know two things about the A and the B. So the A, if I want to know the slope of A, what am I going to do? Well, I need to find two good places. Let's say here and here. I'm going to go up 1, 1, 2, 1, 2. So I have a 2 over 2. So the slope of A is 2 over 2. The slope is 1. Okay, now B, what's its slope? Well, we find a good spot here. Find a good spot here. It's going down 1 and over 2. So down 1 over 2. So the slope of B is down 1 over 2. All right, then we need to know our y-intercept. Well, we found it already, didn't we? We found it right here because there's 0. So the y-intercept is 1. So B equals 1. And for this one, it looks like this is negative 2. I've written over top of it, but you can see that that's negative 2. So therefore, we have an equation y of A. So sometimes I use a subscript letter to remind me which line I'm talking about. So 1x plus 1. So we've kept the numbers pretty simple here to make this easy for an easier example. My y of b is negative 1 over 2x minus 2. So just grabbing those numbers from there. Okay, so we've done this. We've made an equation of both lines. Identify the solution of the equation. Well, these are actually pretty easy because they've given us the answer, the solution right here. We would say that this is our POI. And what would you say it is? Well, it's over negative 2 in the x. So you always put the x first. Here's the x. Here's the y. Okay. So we always go down. So negative 2 and negative 1. So that's our point of intersection. So if this was A, our answer to B is point of intersection is negative 2, negative 1, and it's always written as a coordinate. There we go. And now we want to verify our solution. C wants us to do a check. So we're going to need some space here. We don't have a lot of space, but let's say line A and line B. And so we need lots of room here. Okay, so we're going to have left side and right side, and left side and right side. And so you knew these skills of checking would come in handy. I told you all along that they would, so here we go. Okay, so in this side, when we just focus on A for now, we have just a y here by itself, and we have x plus 1. Getting that right from here. Okay, so what we want to try is, well, here's my x, and here's my y. So we're going to substitute those in. Negative 1, negative 2, plus 1. And we can quickly see that, oh yeah, that's negative 1 and that's negative 1. So that's perfect. That's what we wanted. Left side equals right side. So what we're saying is that this point satisfies this line. It is a solution for this line. I mean, it fits right on that line. And we've proven that on the graph as well. Okay, second, I'm going to take this equation down here and try that out. So again, on this side, on the left side, there's only a y. And on the right side, we have 1 over 2 x minus 2. So the y becomes, again, the same y. We're using the same y from here because we're trying to see if that point works for both equations. Okay, so negative 1, running out of some space here. Good. Oh, I made a mistake there. We're substituting negative 2 into here. Well, this works really well because these two cancel out, making us a whole number here. So negative 1 times negative 1 is a 1, and minus 2 will equal minus 1. So we got it. Left side equals right side. So therefore, our final answer here is, therefore, point negative 2, negative 1 satisfies the system. Satisfies the system. Meaning that that is one point that those two lines share in common. That's really what we're trying to find, is which point satisfies both lines. So that's a really important model to make sure you get a good accurate note written down there so that you can use that to model a lot of other solutions. Okay, moving forward, we're going to solve this linear system by graphing each line and verifying the solution. So again, when we are solving a linear solution, we are looking for the POI. That's really what we need to do. So the words might be fancy, but that's what it's asking us to do. So we always want to translate these questions so that we know what we're actually trying to achieve here. So by solving this linear system, we're finding the point of intersection, and verifying means to check. All right, so we're going to use our graphing skills here. Grab two different colors. And why don't you pause the video, and I want you, because you know how to do this, you know how to graph lines. So I'm going to pause the video and you use your skills. One hint is on the second one, you're going to have to convert it probably to y-intercept form. And let's see what you get. So you go ahead and pause the video and try it. All right, my turn. Okay, so here we have the y-intercept of b equals 1, and we have a slope of 2 over 1. Okay, so let's find that spot. Here's 1, and we're going to go up 2, 1, 2, and over 1. And we're going to grab our ruler and graph that line. And again, you want to be as accurate as possible. Sometimes what I'll do is when they're too close together like that, I'll go up another 2. You can see right there how I made a mistake just by, turning things, just trying to eyeball it too much. So here we go, and then adjust. Now you're going to do it with a ruler, it's probably easier. Good. All right. Now that's our one line, so let's get the second line ready. Okay, we have now we cannot solve it from here, so we're going to have to convert to y equals mx plus b. So x minus 3y equals 12. I don't like when that y is negative, so I bring it over to this side to turn it to positive. And I don't want this 12 with that, so I'm going to bring it over here. And so we have x minus 12 equals 3y. And of course, we need to get the y all by itself. So divide each side by 3. This might have been the one place um, you made a mistake or something, because again, this can be tricky to convert your equations. But we just did it last unit, so this is why we did it in that order. All right, so here we go. So now we have our m. All right, there's our m. There's our b. So negative 4 is down, way down here. We're kind of losing some space here. You have to estimate it, so not the greatest question for this one. But anyways, and we have 1 up 1 over 3. Up 1 over 3. Oh boy, I'm really sorry about this, guys, because this is going to fall way off our grid. So I have a solution for you. We're gonna try. Just give me a second. All right, we could estimate, but it's more of I'm just sort of bothered that I messed that up for you guys. Okay, so roughly, roughly we would say this spot here. So if we're going by this, we're going here, here, so maybe -5, and maybe -3. So let's estimate that the POI is -3, -5. I guess we could have figured it out if we just kept going along this pattern. I've just loaded up Desmos, and that could help us. So let's try this out. It's because we fell off the map here. And I want to show you again, I really want you to think about using Desmos either on your phone or from your another window, because it's such a lifesaver when it comes to accurate graphing. So let's say we had those two graphs again, those two lines. So line 1 was y equals 2x plus 1. There you go, there's our red line. Okay, so in this case, oh yeah, good. And then we can do another one. And here's the beauty of it. You don't even have to rearrange that other equation. You can type it in just like that. So guess what? We weren't too far off from our prediction, even though we had fallen off the grid, because look what we got here. So the beauty about Desmos is you got these two lines, and you can put your pointer right at that, and look what it's giving us for a point of intersection. So -3, -5. So we were right on. So that was great. Okay, so let's keep this out, and we're going to try that on our next one also. But first, we want to be able to do these word problems on our own a bit. The nice thing here is they've given us the equations, which makes things a lot simpler. Okay, we have number 3 here that we can use. We're going to keep Desmos open again because it might come in handy here with this question. First thing I'm noticing is that we just have a bit of difficulty with, I think the scale is not going to quite work out, because if we read the problem here, it would say that the banquet hall is cost $1,000 to rent the hall and $20 per person. So we're already going to be starting at 1,000. So I'm thinking we want to just change that quickly and make our scale. Scaling is it's often the hardest thing to be able to predict. So if we did every 2,000, that might not 20,000, 2,000, that might make it a little easier. Okay, so let's pause here, and we went, okay, we have a banquet hall cost $1,000, and the hall is $20 per person attending. The cost of the hall is represented with this equation. So that's nice. They give us the equation to start with. C is the total cost, N is the number of people. We want to graph this equation. Okay, so I believe the first line last time was red, so we're going to, in the Desmos, so we'll see. So let's say we start at 1,000, okay? And then what I would do is, since we're going up 1,000 every time, I wonder if we could say how many $20 would go into 1,000. So that's probably 550, I think. So we would want 50 here. Now 50 doesn't work out that great because we scaled by 20s here, which is a little different. But okay, so we can get 50 pretty good here, though. So we know that in another thousand, it took another 1,000 to jump, and we saw how many times would 20 fit into 1,050. So you could come up with some better numbers, like if you wanted to say, if you knew every 5 um, people was going to be 100, right? Then every 20, so you could say, okay, well, what's it going to be at 20? So 20 times $20 would be 400. So you could get some other spots here. So at 20 people, we'd be at another 400 right here. And then probably at another 20 people, we'd be another 400. So there we go. So you can see we're on a good track. All right, we can get a red line here. I don't know if they pick colors. There we go. No, I want a line. Thank you very much. Okay, there we go. All right, so you can see it can be time consuming to do all the lines, but get some colors here. Okay, next. Another hall charges $40 per person, but and the cost of the banquet is represented that. So it includes the banquet rental. There's no pre-payment for the banquet rental. So C is cost, and so that means there's no B. The B is 0. So we start right at 0. And so you can just quickly do a couple things like, okay, well, what's 40 times 40? 40 times 40 is 1,600. Now, not a perfect number. We might want to try something different, like 2,000 or something. But roughly, that would get us to, actually, it works out pretty good because we're going up by 200s here. So 1, 2, 3 is right there. And so we could graph that. If we want to be a little more sure, we could see what it would be at 60 or something like that. 60 times 40 is 2,400. So here's 2,000, 2,200, 2,400. So we're getting exactly what we wanted to see here because we're getting a crossing over. So it started low. So you might think, oh, we're saving a ton of money here by not paying for a rental, the $1,000 rental at first. Okay, so yeah, you're saving a lot of money. But let's say, this is a wedding or something, you're going to go over 50 guests probably. Probably pretty simple. Pretty often you're going to do that. So, or maybe you're having a small party and you want to keep this low slope. Either way, you can now see that we have reached a point of intersection, and it is actually at that 50 marker. even though we just sort of guessed that. And so we could say our point of intersection is 50 along here and 2000 as far as we can tell. Could be a little off, but we'll see. All right. So then it says, compare the two graphs. At which point is the cost the same no matter which banquet hall you rent? When is it cheaper to use one versus the other? Okay, so first point, um, costs are equal at 50 guests for $2,000. Okay. If less than 50 people, go with option A. If more than 50 people, go with option B. So that's the type of thing. Now the question is, if you had exactly 50 people, maybe go with option B in case a couple more people show up or something. But here we go. Now I wanted to show you again what the advantages of using Desmos could be. So even just to verify your answer to make sure you're right, or if you don't have graph paper printed out, or you don't have um, accurate rulers, or you weren't able to print all this stuff and you're working off a tablet, then um, you could work on Desmos, and then you could probably save your graphs, or even take a screenshot of them. All right, so now they won't let you use C and they won't let you use N. So you try that out, look, and it's going to say, I don't think it's going to let you. It did. Wow. Okay, that's different because I tried it last week, and maybe that's a common enough one that it lets you do it. So that's great. That's really good news. You'll notice our scale isn't working very well. So we might want to adjust that. So let's just see what happens next. So we'll do the next one. C equals. Again, like we don't get anything out of this. So what we do is we go here. Okay, and you want to have your x-axis start at basically, I would go -5 just so you can see a little bit of the border. And how far do we want to go on our x-axis? Well, look at our rough estimate here. We went to 80 before. Okay. And then our y-axis, well, that one's the one that's really messed up because it's so stretched out. Again, -5. We need to go all the way up to, well, let's just give ourselves lots of room and say 22,500. And I think that should work. Okay, so, oh, my screen's a little low, so. Oh, you know what? It says 100. Look back at the first equation. Let's make that 1,000. Okay. I just have to adjust it because I think my window is a little low. All right, so you want to see where that ended up? We hover over this point and we see again 50 and 2,000. Perfect. So we did well there. And so you could probably screenshot this, or I wonder in the options. Can you print? There's got to be something. Share your graph. There you go. You print it. You export your image. You could copy it. I could copy that and then pull up a new Word document. Let's see if this will work. Oh, and paste. Oh, that's not what we meant to do. Export the image, I guess. Oh, and then you could download it as a ping. And then you could upload it into something. Insert image. See if I can find that quickly. And just gotta remember where I put that. And there's our graph. And easy as that. Like how awesome is that, eh? So, and then from there, like to make it fit with your work, like let's say you're doing this on a test, right? And you decided to print your test off and then do the handwriting, but you want to get a nice graph. That's good. Oh, there's another thing I wanted to show you. How useful this is. The other thing we didn't add here was you can call the label. So that was the x-axis was number S, and y-axis was equip cost. And you can put dollar signs in there. And it's just really nice the way it labels the axes for us. A little strange that it's on that side. Oh, just move it a little bit and they adjust for that. So if we save that, it would look professional, look nice. And so I hope you'll use this tool to your advantage to help you out. Okay, so we left off with that last question, and that was what we were doing. So, well, we're doing our homework, I guess, would be BLM. This is 5-1-2 -1-1. There was also before that you could have done BLM 5-getting ready GR1. But if your getting ready one is really easy, just skip to the 5.11. Okay. So thanks for joining in and watching, and good luck.